Hello, and welcome to Math with Mr. Bill. I'm Bill Anderson, and today I'm going to be working through a series of 6 problems to help one of my students get ready for his exam. Please put questions in the comments below, and feel free to post more problems there as well. On to question number 3. Use the 2-point slope limit process to find the slope at the point 2, negative 2 on the function x over 1 minus x. So in other words, this is going to be using the definition of the derivative to help us to find the slope at a particular point. So to find the slope at a particular point, there's all the derivative rules, of course, but before that, we have to know the definition of the derivative. And so what we do when we do this is we have a particular point here. This point here, 2 comma negative 2, that's our particular point. And then we got to come up with a generic point that we're going to bring closer and closer to the point 2, negative 2. And then take the limit of that getting closerness and then find the slope, find the actual slope. So in other words, we're going to find the limit of the slope between 2, negative 2 and t f of t. So t f of t is going to be the generic point. So the limit of the slope, well, let's find the slope first. So the slope here is going to be equal to, well, it's the difference in the y values. So it's f of t minus negative 2 divided by the difference in the x values. So rise over run. And then we'll want to take the limit of that. We're going to find the limit. Now the limit of what? So the limit as something approaches something. We'll take a look here in just a second, and we'll be able to determine what that is fairly quickly. What we want to know is what happens as our generic point gets closer and closer to 2, negative 2. So in other words, I want to know what happens when the t value approaches 2. Okay, so now we've got this f of t in there, and we've got to figure out what f of t is. So if f of x is equal to x over 1 minus x, then f of t is just equal to t over 1 minus t. It's just a simple variable change. So nothing too complicated there. And so we're going to go ahead and substitute that in and figure out what to do next. So we have the limit as t approaches 2 of t over 1 minus t plus 2 all over t minus 2. So now we have some algebra to do, because the thing is I can't plug 2 into this limit. It'd be really nice if I could. And if I do that, I'll end up dividing by 0, and it won't work. So I have to do some algebra to this, which I'm allowed to do. By the limit laws, I'm allowed to do legal algebra inside the limit to make it simpler. So the thing that sort of screams out to do something is something on the top. So we've got this fraction here, and we're adding another number. So why don't we get a common denominator between those two and see what that gives us. So I'm going to multiply the top and the bottom of this 2 by 1 minus t over 1 minus t, because all integers can always be written as a fraction as the integer over 1. Okay, so let's go ahead and distribute that 2 and go ahead and combine both fractions, and we'll see what that gives us. So that it's going to have t plus 2 minus 2t all over 1 minus t, and then that whole thing will be over t minus 2. So we have this fraction up on top, and it's going to be divided by t minus 2. Okay, so now let's continue simplifying, continue bringing things together. So we have the limit as t approaches 2 of negative t plus 2 over 1 minus 2 over 1 minus t all over t minus 2. Okay, so far so good. Now I have a fraction over the divisor. I can make that into a fraction as well, t minus 2 over 1. And the reason I'm going to do that is because I want to then be able to take and flip it, take the reciprocal, and then multiply it to the numerator's fraction. So that's going to help me be able to simplify this down and be able to get rid of the problem, right? The problem that's sort of staring us in the face is that I can't plug 2 in, because if I do, then I'm going to be dividing by 0. So get 1 over t minus 2. Okay, so now what happens now? I don't have anything to cancel. Like, I can't cancel the t minus 2. But up on the numerator of the first fraction, I have minus t plus 2. That's the complete opposite as the second fraction's denominator. So if I pull a negative out of that, I'm going to get the term in the denominator, which is great because that's got to be canceled in order for me to be able to find the limit. Or there's the limit ends up being infinity or negative infinity, and it's not very helpful. So t minus 2's cancel, and now I am able to plug in 2. And so when I plug in 2 into this, I get negative 1 divided by 1 minus 2, which is going to be negative 1 over negative 1, which is going to be 1. So the slope of the function at 2, negative 2 is going to be 1. And we write that out. We can use the prime notation here. So f prime at 2 is going to be equal to 1. And if we wanted to, we could use the quotient rule to double check our work. So we'll write down the function again. F of x is equal to x over 1 minus x. And when we have a quotient like this, so we have some h of x over g of x, and we want to take the derivative, the formula looks like this. H prime of x times g of x, so the derivative of the top times the bottom, minus h of x times g prime of x, the derivative of the top times the derivative of the bottom, all over the bottom squared. So putting in the pieces now, I get the derivative of h prime of x, well that's going to be 1, because the derivative of x is 1, times 1 minus x, minus h of x, which is x, times g prime of x, which is negative x, or negative 1, all divided by 1 minus x squared. So that's f prime of x using the quotient rule. And then we're going to plug in 2 for x. And I could go ahead and simplify it, but I'm not going to, because we can just plug 2 in. So I get 1 times 1 minus 2 minus 2 times negative 1 all over